Okay, Mr. Rashid back here. So we are taking situations now and we're going to convert those into piecewise functions. And in this particular example, we're going to convert it into a function and a graph in this case. So let's go. Let's take a look. So remember what I said in one of the past videos is that the the boundary is where something changes in your situation. So like in a physics problem, for example, a ball's traveling through the air and then slams into a wall and gets stuck in that wall or something, then something happened at that boundary where the it was traveling perfectly fine, but it hit that wall. Now you will encounter, right, in these situations a something that will change, and that is going to be your boundary. So in this case, we have a person, Edgar. He's got nothing else to do, so he decides to spend some time playing on the elevator in this tall building, and he's going up and down these floors on the elevator. Now, the first thing is in many cases, you'll be given just a blank graph with your y coordinate and your x coordinate. And let me help you out here. Time, wherever time is in problems, in let's say 95% of the cases you're going to deal with, and I would say 100% of the cases in this class, unless you're dealing with like black holes or space-time communication, like our GPS satellites, or quantum mechanics, all things you'll look at in college. Unless you're dealing with those things, time is going to be on your x-axis. So in this case, he's moving up and down the floors on this elevator, and time, meaning what's happening to him, what floor he's on, it varies depending on the time. And so time is on the x-axis. In this case, we're talking about minutes. And so on the y-axis then, it's moving up and down on the floors. So we're dealing with the floors of this building. So it could be the 10th floor or the 12th floor. We'll see what's happening with this story. So let's start. So on the first floor, Edgar presses the up button. So we'll assume, so time starts at 0 minutes, right? When you start your stopwatch, it starts at 0 minutes. It doesn't start at 1 minute. So we're going to start at 0, and he's on the first floor at 0 minutes, it looks like here. So on the first floor, Edgar presses the up button, then waits 6 minutes for the elevator to arrive. So all the way from 0 to 6 then, 0 to 6 minutes here on our graph, he's going to be at this first floor. So let's say we draw this line here, and I know at 0 minutes he's on that first floor, so I can plot that. And at 6 minutes, he's still waiting for that elevator. So I know for sure, even at the 6 minute mark, he's still at that, on that first floor. So what happens next here? So he presses the up button on this elevator. He gets on the elevator and decides to go to the 14th floor. It takes 2 minutes to get to the 14th floor. So I know then at 6 minutes here, so at 6 minutes here, he's on that 6th floor, but then let's use a different color. It took him 2 minutes to get to the 14th floor. So for these two minutes here, from there to there, so this can be our other boundary here. So from 6 to 8, he's on this elevator and he's getting to the 14th floor. So at the end of this 8th minute, I know for sure he is on the 14th floor. Now I can draw just a straight line if you have a ruler. I'm going to freehand this here. but my slope is essentially 14 minus 1, so 13 over 2. My rise is 13. He's going from the 14th to, or first floor to the 14th. That's 13 stories up, and that takes 2 minutes. So let me try to freehand this line here. Okay, well, not too bad, but still, use a ruler if you've got it. So on the 14th floor, then, let's see what happens here. It takes 2 minutes to get there. Then the elevator takes 5 minutes to go up to the 24th floor. Oh, okay. He doesn't pause there at the 14th floor. He just keeps going. And this time, I don't know, something in most buildings, the elevator is going to move at the same rate, but in this building, it seems it gets slower as it goes up. So it takes him 5 minutes to get to the 24th floor. So we're at 8 here, 8 minutes now in this story. So 5 more minutes is going to bring us to 13. So 13 is over here. And he's not pausing at all. It looks like at this 14th floor, he's just going to go straight up to what floor? The 24th. So we can say at the end of this, on this boundary, right, where this part of the story, he's at the 24th floor. So that's a rise of 10. We're going up 10 stories and a run of 5. It took us 5 minutes to get there. So I'm going to freehand this again. Okay, that's better than last time. So, and this is a continuous function, so he starts at that 14th floor point and then he goes up to the 24th. So let's see now what's going on. So now Edgar and the elevator then spend 4 minutes getting to the 3rd floor. Okay, he's not pausing at all. This is a fast elevator. So spend 4 minutes getting to the 3rd floor. So let's use a different color now. So 4 more minutes from the 13 is going to bring me to 17. So I can set up a new boundary here at 17, and he's going all the way to the 3rd floor. So this is where I'm going to end up. This is my line here. And now I'm going to freehand this line. Okay, so he's going all the way down. And at that point, the electricity went out in the building, so he was stuck on the 3rd floor for 7 minutes. So I'm at 17, and let's go to a different color here. So he's just stuck there on this 3rd floor all the way to, what is this? We're starting at 17. We've got 7 more minutes. So all the way to 24. So this is my new boundary. So he's at, we know he's there at 7 minutes later, and we're just stuck there. So that's just on the 3rd floor for that time. Then once the elevator starts working, it takes 1 minute to go to the 4th floor. So this is our final boundary then. Let's go back to this. So it's a very short boundary there, and we're just going up 1 story to the 4th floor, and we've got this little line there. Don't know if you can see that very well, but there it is. That's the line, and we are done. That is the graphical representation of what's going on.